AI does not know your company documents by default. It does not know your HR policy, your IT policy, or your security handbook. So if you ask a general model a private company question, it either refuses, guesses, or gives you a generic answer that sounds helpful but is not grounded in your real material. That is the core problem RAG solves. RAG lets your app search private documents at question time, put the right pieces into the prompt, and ask the model to answer from those pieces. In this tutorial, we are building a private document chatbot in C# that answers from sample company files and returns the source it used. The goal is not a magic chatbot. The goal is a workflow you can inspect, test, and improve. The demo is an internal policy assistant. We will give the app 3 sample documents: HR policy, IT policy, and security policy. Then we will ask a question an employee might ask: what is the password reset policy? The answer should not be invented from the model training data. It should come from the IT policy file. It should mention that password resets go through the IT service desk and that multi-factor authentication is required for corporate accounts. Most importantly, it should include the source, itpolicy.txt. That source is what makes the answer inspectable. A user can open the file and confirm the answer. A developer can debug retrieval if the wrong file was selected. A reviewer can decide whether the document itself needs to be updated. Before the theory, here is the workflow we want. The user asks, what is the password reset policy? The app turns that question into an embedding. Then it searches the vector index for nearby chunks of policy text. The top match is the account access section from itpolicy.txt. Now the model receives the user question plus that retrieved policy text. It is not asked to remember the policy. It is asked to read the context and answer from it. The final answer says password resets must be requested through the IT service desk, multi-factor authentication is required for all corporate accounts, and the source is itpolicy.txt. That source line matters. Without it, this is just another chatbot. With it, we can inspect exactly where the answer came from. RAG stands for Retrieval Augmented Generation. The simple version is this: search first, answer second. The model does not magically learn your documents when you connect it to an app. It still has its general model memory, and your private documents still live outside the model. The retrieval layer is the bridge between those two worlds. When a user asks a question, your app searches your document index, picks the most relevant chunks, and places those chunks into the prompt as context. Then the model generates an answer using that context. For enterprise apps, this mental model is important. The model is not the database. The database, index, metadata, permissions, and evaluation process are your responsibility. RAG has 2 main flows. The first is indexing. This happens before the user asks a question. Step 1 is load documents. In our demo, those are plain text files. In a real app, those might be PDFs, Word documents, wiki pages, support tickets, runbooks, or internal knowledge base articles. Step 2 is extract text. Text files are easy. PDFs, scans, tables, and old exports are where quality problems start. Step 3 is split the text into chunks. The model cannot search one huge document directly, and vector search works better when each unit is focused. Step 4 is create embeddings. An embedding is a numeric representation of meaning, so similar ideas end up close together. Step 5 is store vectors with metadata. Do not store vectors alone. Keep file name, title, section, page, updated date, and permission tags. That metadata is what makes citations, filtering, and debugging possible later. A useful indexing pipeline should also be repeatable. If a policy file changes, you need to reindex it, replace the old chunks, and keep the vector store in sync. For a beginner demo, you can rebuild the whole index on startup. For a real app, you usually want incremental indexing, document versioning, and logs that show exactly which files were indexed. That is how you avoid stale answers from old policy text. Chunking is one of the easiest places to break a RAG app. If chunks are too small, they lose context. If chunks are too large, the answer gets buried inside too much text. In our policy example, imagine the password reset rule is in one chunk, but the multi-factor requirement is in the next chunk. If retrieval only returns the first chunk, the answer misses an important part of the policy. That is why we use overlap. Each chunk shares a small amount of text with the chunk before and after it, so related rules do not get separated too aggressively. For this demo, simple paragraph chunking with overlap is enough. In production, tune chunk size based on document structure and real user questions. Policies, legal docs, API docs, tickets, and meeting notes usually need different chunking strategies. A good practical starting point is to chunk by headings or paragraphs first, then enforce a maximum token size. That keeps sections readable while still protecting the context window. Also store the chunk index and neighboring chunk ids. If a retrieved chunk looks incomplete, you can fetch the previous or next chunk as supporting context. After chunking, we create embeddings for every chunk. Think of an embedding as a coordinate for meaning. Text about password resets, account recovery, and access control should land close together. The user question also gets embedded. Then vector search compares the question vector with the document chunk vectors and returns the closest matches. This is why RAG can find the IT policy even if the exact words are not identical. The search is based on semantic similarity, not only keyword matching. You can still combine vector search with keyword search later, but the beginner mental model is: embed the question, search nearby chunks, then pass those chunks into the model. In C#, keep embeddings behind an embedding service so retrieval can be tested separately from generation. The most common mistake here is treating the top result as automatically correct. In practice, you usually retrieve several chunks, rank them, and pass only the best evidence to the prompt. You can log the similarity scores, source files, and chunk ids every time a query runs. Those logs become incredibly useful when users say the assistant gave a weak answer. The second flow is the query flow. This happens every time a user asks a question. First, normalize the question if you need to, then embed it with the same embedding strategy used during indexing. Second, search the vector index and get the top matching chunks. Third, apply metadata and permission filters. That part matters in a company app because not every employee should retrieve every document. Fourth, build a grounded prompt that includes the retrieved context and the user question. Fifth, call the model. Sixth, return the answer and the source metadata. This is the difference between a generic chatbot and a private document assistant. The model is only one part of the system. The retrieval pipeline decides what evidence the model is allowed to see. If the retrieval step returns weak matches, the model should not be forced to invent a strong answer. Add a minimum score threshold, and when the top chunks are not relevant enough, tell the user the answer was not found in the available documents. That is much better than a confident hallucination. The prompt matters. You do not want the model to freewheel. You want it to answer from retrieved context. The key instructions are simple. Answer only from the provided context, say you do not know when the answer is missing, and include the source file for every answer. This does not make the app perfect, but it gives you a clear contract. The model is not being asked to remember company policy. It is being asked to read the retrieved policy text. In production, you can also add formatting rules, citation rules, and escalation rules. For example, if the context is conflicting, say there are conflicting sources. If the retrieved chunks do not answer the question, do not guess. That is how you keep the assistant useful without pretending it is all-knowing. I also like to separate system instructions, context, and the user question clearly. Do not paste everything into one messy string. Use labels, delimiters, and a predictable response format. That makes it easier to test and easier to parse if your UI wants to show answer text and citations separately. Source citations are not decoration. They are how users build trust in the answer. If the app says password resets go through the IT service desk, show source, it policy.txt. If you have section, page, heading, or last updated metadata, show that too. Citations also help the developer. If the answer is wrong, you can inspect whether retrieval found the wrong chunk, the document was outdated, permission filtering removed the right chunk, or the prompt allowed too much guessing. Without citations, every failure looks like a model problem. With citations, you can separate retrieval failures from generation failures. That is one of the biggest practical benefits of RAG. For an internal assistant, citations also change user behavior. People stop treating the answer as a black box. They click the source, read the policy, and catch gaps in the documentation. That feedback loop is what turns a demo into a useful workplace tool. Here is the actual C# shape I would use for the tutorial. Start with small records, chunk metadata, document chunk, and search result. Chunk metadata keeps the source file, section, and chunk index. Document chunk keeps the text plus that metadata. Search result keeps the chunk plus its similarity score. Then load the sample policy files, read the text, and split each file into chunks with overlap. Next, embed every chunk and store the vector beside the original chunk. When the user asks what the password reset policy is, embed the question and search the vector store for the top matches. Apply a score threshold so weak matches do not get forced into the prompt. Then build a grounded prompt from the retrieved chunks. The prompt should say, answer only using this context, say you do not know if the answer is missing, and include the source file. Finally, call your chat service and print the answer. The expected result is a policy answer with source. It policy.txt. This is the difference between theory and a working RAG flow. Metadata travels with the text from load, to chunk, to vector search, to final citation. Now the issues that break real RAG apps. First, bad text extraction. If PDF extraction is messy, retrieval will be messy. The model cannot fix missing or scrambled source text. Second, poor chunking. Chunks that are too small lose context. Chunks that are too large bury the answer. Third, no metadata. If you do not store source file, section, page, updated date, or permission metadata, you cannot cite or filter properly. Fourth, no permission filtering. In a real company, not every user should retrieve every document. Your retrieval layer must respect access rules before context reaches the model. Fifth, embedding mismatch. Do not index with one embedding strategy and query with an incompatible one. Sixth, sending too much context. More context is not always better. It can dilute the prompt, increase cost, and make the answer worse. Seventh, no evaluation dataset. You need test questions with expected sources. For this policy assistant, one test question asks about password resets and expects it policy.txt. Another asks about vacation and expects hrpolicy.txt. Another asks something missing and expects I do not know. Evaluate retrieval, not just final answers. A good evaluation table has the user question, expected source file, expected key facts, and notes about whether the answer should refuse. Run that dataset whenever you change chunking, embeddings, ranking, or prompting. If retrieval gets worse, you want to know before users do. This is where serious RAG work happens, measuring whether the right evidence was found before judging whether the final sentence sounds good. So the mental model is simple. Private documents do not live inside the model. Your app retrieves the right context first, then asks the model to answer from that context. For our policy assistant, that means the user asks about password resets, the app retrieves the IT policy, and the answer includes the source. The important pieces are chunking with overlap, embeddings, vector search, a grounded prompt, citations, metadata, permission filtering, and an evaluation dataset. That is the foundation of a useful private document chatbot. Follow for more AI dev workflows.